Welcome to ICE Education. My name is ICE, the only education that matters. This introduction manager is gonna hit South Africa and the world soon.
Very true, man.
Okay, my
You
brother.
must also put some, what they call it, those effects.
Like let him cook.
Mm. Or people clapping.
Yeah, I think you can make that interesting, ne? When you want to explain something, you say it's time to cook.
Yes, sir.
Okay, can you see my screen? I'm just gonna go through here explaining quickly and we're gonna move to what is important, no? How to
Okay.
solve and what, so there's nothing. And we're gonna move to application. So we've got second order partial differentiation equation. How they are calling it PDEs. There's a lot of PD
P-
thing here. PDG, PD what? PDD.
Okay.
The general form linear equation of the order partial differential equation PD in two variable x and y is given by a is equal to whole square u plus b whole square d plus c plus d plus e plus fu to be equal to g, where a b c. Don't worry much about this, no? It's just
Mm.
some math explanation. Where a b c and d f, you will not be asked something like this. Don't worry. They're just explaining to you first. A function of x and y, when gx is equal to gxy is equal to 0, the equation is said to be non-homogeneous. Otherwise, it's a non-homogeneous. Okay, basically what I want to show here is you can have partial derivative. They are usually homogeneous and non-homogeneous. How do you know that this is homogeneous or non-homogeneous, manager? Here is one example. If you have this type of function, like this, equal to 0, your thing is homogeneous. If your function
Okay.
is equal to a certain function f of x, it's a non-homogeneous. Are you with me, manager?
Yes, sir.
Yeah, don't worry. Okay, especially don't worry about it. We're gonna get to the part that's where what's important. Now they say a solution of a partial differential equation in two variable xy is a function uxy that has all partial derivative occurring in the equation and satisfy the equation in some region of the xy plane. The solution we seek is in the form of the product uxy, xj, yj. The method will be used in this section to obtain solution is separation of variable. I'm pretty sure you've heard of separation of variable in
Mm.
previous how can I say, in previous level. Mm. The separation of variable method reduces the linear partial differential equations into ordinary differential equation. Note that rho ux is xy, rho uy is xy prime. Okay, this is very important. Have you heard of separation of variable, manager? I think your
Not
logic
really.
skillers had something like that. Why do we separate variable? You can have let's say 2x squared plus 2y, and then here you have y squared plus x. Why do we separate variable during those integration? We simply want to keep the y and the y, the x and the x. That's why we call it separation of variable. You cannot have two variable on the same side. Do you understand?
Yes.
In this case, if you want to separate variable, you'll have 2x cubed to be equal to what? 2y cubed. Now you have separated variable. In mathematics 3 we used to differentiate after that. But don't worry about it. What I want to show you is separation of variable. Why do we separate variable? The simple reason is, okay, I really like to use math like in real life. If there's a group, okay, have you seen people vending, like people that work for, let them, I don't know how to say it in good English, people that had a work for Twitter.
Mm.
Yeah, they were a group of men. I'm pretty sure women as well. If you had to count how many men were there and how many women were there, what will you do?
by separating them.
That's the simple reason. Math is simply like life. Actually, everything that we do, I can relate it to life. So if you have two different variables, you have x and y, you separate them. That's what they mean by separation of variable. Because you have two different types, you have to separate them.
Noted.
Now, when I said, did you work? You should have gone to the work.
Sorry?
Did you work for 12?
Oh, unfortunately I didn't.
Okay.
But I'm supporting.
Yeah, we all support it. Okay, manager. Separation of variable reduces the linear partial differential equation. Now, what I want you to know is, let's say, okay, you have to get used with this expression. If you have partial u, partial x, in terms of separation of variable, what does it mean? It means you have x prime y. That is what it means. You have to be familiar with this. We're gonna move to the place where we need to cook. So you have to be able to notice this. Same apply here. If you do have partial u, partial y, it simply means y is the derivative, x is the way it is. Do you see it, manager? If I have
Yes.
partial
I'm
u,
following.
partial x squared, it simply means x is second derivative, y is the way it is. Math is easy, manager. It's very easy. Same apply also with this guy. If you have partial u, partial y square, you do have y to be second, x alone. Do you agree with me? Now let's go. Tonight is gonna be a great class. I don't know why I feel like that. I love it.
Ice education is great.
Example 5.11. Find the product of the solution of this partial differential equation. What do they mean by that? Now, do you see this equation here, manager? Let's copy it. It is what?
It is d squared u
This
dx squared.
Let me answer that question. Eli, you want to answer the question on Monday? You x square. Yeah, manager.
Yes,
That
master.
video of let me answer that question on Monday always kills me.
Yeah, no.
Okay, manager. For partial u, partial y. Okay. Now, what is the question? They said find the product solution of this partial differentiation. From what we have here, manager, what did I say? I said when we want to write, why do we separate variable, manager? We separate them because you have two different variables. I don't know how to say it. I've taken an example of
Okay, people.
people who had a work.
Yes.
If they had to take how many girls and how many women and how many men, you need to separate them. Now remember, earlier on, I've shown you how to write this in terms of x and y and in terms of what then. So can we write this in terms like that, manager? What does this expression mean? This expression simply means you have x second y.
True.
It's just what I've shown you here. So you have to be familiar with that. It's very important when it comes to application on what we're going to do just now. To be equal to what? 4. Where there is u, so it means you're going to be having x and then you're going to be having y. Remember, I said separation of variable is keeping the same gender together, the other gender together. Male on one side, woman on the other side. Because when I say gender, it's sounding rude. I don't know why it does. Do you agree for me to get this guy? I can write like this, and I can also write like this. Now you have separated variable. You brought the y together, you brought the x together. That's the first step. Are you with me here?
Yes, sir.
That is why you see this solution like this. Oh, what they prefer here, they prefer having this constant coming down here. It's just preference. I think it's for the sake of the solution. What they say is they would like keeping, let's say they bring 4 down here, they like these to be alone. So now you have separated variable, and then here there is a whole theory behind it that we will be doing on the application. But for now, let's just read through it, manager. They says both sides of the equation are independent of x and y. So each side of the equation must be a constant. That's what they mean. For convenience, we choose the constant as lambda square or minus lambda square. Okay. They said case 1. Remember what they want, they equating this to be equal to a constant so that they can solve. They said case 1. I'm just explaining, we're gonna do the example, you see how it's done. Case 1, they said if lambda square is greater than 0, then x second over this to be equal to what? Lambda square. So it means you equate this to lambda square. It means here you will equate this equation of x here to be equal to lambda square. When you bring it, if you try to solve it, you will see this expression. But don't worry, you will see as we solve it. I'm just explaining. Now you do the same with y. Then if you solve, you're gonna get x is that solution, y is this solution. I will explain it. If you come to if is less than lambda square, you have this equation like this. You have this one, and then you have this one as solution. Respectively, u is equal to this, where a, b, c, that leads to this. Do not worry about this, manager. You will see how it is solved. It's just an explanation. It's better we do it through an example. Now they said classifying second order differential equation where a, b. What I want you to see first is how to split this. You will see as we solve it. A, b, c, d are real constants said to be hyperbolic, parabolic, and elliptic. Okay, now they said classify this partial differentiation. They have this. Solution, they said, writing this and this, we identify a is 3, this constant here, b is 0, c is 0. So you have b square minus 4ac is parabolic, okay. Use separation of variable. You can do separation of variable for this one, right, manager?
Yes, Mr. Ice.
Can you do of this one?
Yeah, I can.
It's just what we've done here. Just
Yes.
yeah, just that's what they want you to know, and that's what I want you to know so far. Is this one, how to separate variable? But this is where you'll be having the main problem for your test when it comes to heat equation.
Okay.
This is where we're gonna be focusing right now. Now, those separation of variable was just to show you that you're gonna need it on the application here. Now, let's move. They say the heat equation. But if someone is born in 1999, how old are they now? 26, right? 1999 is not 26. They are growing. They are growing.
Yeah. Very,
Okay,
very grown.
Raja, let's review. They said application of second order partial derivative. the Higgs equation. We start by principle of looking at a thin rod of length L. This is a thin rod. The length of the rod is from, can you see, from here to here, right?
Mm.
They say the ends of the rod are where x equal to 0. The ends of the rod are where x, that's not the end, that's the beginning. But okay, it's also an end. They say the ends, okay, there are two ends, this one and this one. The ends of the rod wire are x equals 0 and x equal L. The English makes sense here. Assume that the temperature is constant at every x point. It means along every position here. Do you see what I mean? Manager, do you see the insulated
Yes,
segment
my
of the
friend.
rod? From x0 to xl, it simply means you have different values of x in between.
Okay.
Those values of x here, they are the one they say that the temperature is constant. So even if it's x equal 1, x equal to that temperature is the same. Now they say the diagram below illustrates the concept of heat flow and the corresponding partial differential equation model with accompanying conditions. Now, I will show you. This is a function of u, x, and t. The variable. Why do you think you have two variable, manager? You have x and t. Why do you think of that? Why do you think in this case we have these two variables? Remember this statement. Temperature is constant at every x. So we have two variables. We have the temperature and the displacement. That's why in your partial derivative here, they have partial of x, ux, and then partial of ut, because you have two variables, which is simply x and the temperature. Am I making sense? I know it
Yes, sir.
still sound like Chinese, but it will look nice. Don't worry. The one-dimension partial differential equation representing the system is, this is the general form of the heat equation. That's why when you will be coming to question even, where are the questions? When you will be coming to question on heat equations, where are they? You will be having these forms and condition. Where are these questions? Okay, that's wave equation. Okay. No, that one is something else. We are not doing polar coordinate and whatever that is here. We are only doing heat equation. What is page 78? Let me check from the textbook. Uyajola. Naja, do you watch Uyajola?
No, not really. Do you
Okay.
watch?
There's heat equation and wave equation. So we're gonna do the two. Me? Sometimes. But I've watched them all the new season.
Yeah. Oh, they mean the new season. You've been watching the new season for this season what? Season 11.
No, those Uyajola, they are movies. Those Netflix movies, not Uyajola for Jab Jub or what.
Oh, Umjolo.
Nah, that's Unjolo, ne?
Yeah. Those three, is it three or four of them?
I watched them all.
What do you say about them now?
I
Your
just like the
review.
fact that I'm watching a movie and that movie is for the people that I see around, the language that I hear around. That's what I like.
Mm.
And what else do I watch? I also watch adulting.
Yeah, I've been adulting.
Mm.
But then, what's your review on those on South African series?
And
Are we going in a good route?
nice, everything is good. The quality of the image, the stories, the actors, yeah, they are doing good.
Yeah, man.
They are
Even the
serious.
story writing,
Mm. They are serious about their life.
very true.
Yeah, those actors, they can act.
Yeah. They're very good with the eyes.
Well, anyway,
They're very good. So what do you know?
let's go back to the cooking. Okay, manager, if you have this equation like this, K, this is the general equation of this.
Yes.
That's the general equation. We're going to look at this example together. We have K, which is partial U square, partial X square, partial U equals to C. This is the general equation for each equation. It has been derived, I don't know who find it, but someone come up with this solution if you want to calculate.
Or the one for K.
No, not for K. K is just a variable.
Okay.
You see in other places, K is just the number here. It's just a constant. What I'm talking about is this partial derivative here of x and time. Someone has come to this conclusion to say that if you use this formula, you'll be able to solve different problem as it comes to each equation through a semiconductor, through an insulator conductor. So it means you can solve those problems that you face at work where you have a semiconductor using math. That's how powerful math is if you can use it in your advantage. Now, manager, this is the general form. They said k should be greater than 0 and x must be between 0 and L, as you can see. So what does it mean? You cannot have -1 and what here. I don't know if you see what I'm saying. Those values has to start either it is 0 and most of the time it's 0 to whatever value that is here. Do you see what it means? And you have other condition. This one you see as we solve, they are called boundary condition. You have a boundary condition when x is 0. That's what it means. Remember, u is a function of x and t. Do you see it? If I can explain it to you easily, u here is covering two variables, x and t. That's one of the reasons why we're talking about separation of what variable. Now, you have boundary condition. First condition that they say is, if x is 0 and t exists, this is equal to 0. Second condition is, if x is L and t equal to 0, t is greater than 0. And if x exists and t is 0, is equal to the equation f of x, which is between 0 and xl. I know it sounds crazy. Let's move to the solving. I've been stuck in one place for long now. They say the function of ut to the operator when x, the insulated ends, are represented by the boundary condition BCS, u 0 t equal to 0, l t equal to 0, t greater than 0. The initial condition IC is given by ux0 and fx. We assume that at time t equal to 0, the temperature is known. For example, to be some function f of x, using separation of variable result in the solution of the equation in the form ux is equal to this and this. Now let's look at this example, Mr. Manager. Alright, they said, suppose a thin wire of length L has initial temperature f of x to be equal to x. Remember, they said this third condition here should be equal to what? F of x. So the nature of the f of x they told you is what? X. And it will even gonna be given under the condition here. And at the ends at the temperature 0 for all time t greater than 0. If the system is modeled by the equation 2 whole square ux square rho t greater than 0, it is simply this condition here. T greater than 0, these are the boundary condition as it was given here. You don't have to worry about it. You see how it is done. This is equal to the function and then this. They said determine the solution of uxt of the equation at any given time. So this can be given to you for a thin wire length. You have the length, you have maybe the equation, and they say at work derive the equation and discover. That one is a bit advanced level where you can use MATLAB to find out what are the different scenario, what. but for now it's just a matter of deriving the equation. And yeah, now what do we do, manager? This is the equation, do you agree? What is the equation? And it will always be given like that. You have 2 partial u, the partial u square.
It's gonna be 2
Partial square, partial square, partial
u.
square x square. This will always
Yeah,
be like this. Is partial square x square or partial u x square? Partial x square.
partial x squared, which is gonna be equals to partial u.
Manager, please practice, please.
Yes, Mr. Ice.
Partial u over
Partial t.
partial t. Now remember, what does this mean?
Yes, sir.
Without thinking, we use our separation of variable. What does this mean? We have 2 partial u square x square. This looks a bit different. It looks a bit different. Yeah. Those partial derivatives we're working here for rho u, rho x, and rho u, rho y. In this case of each equation, the variable is x and t. So how do you separate these variable, manager? As simple as that, because you have the second derivative here, rho square u. You'll be having x second on top, and this one should be x. And you see? That's how it is. Now, to be equal to, on this side, because it is rho u, you'll be having I think you'll be having t prime over t. That's how t prime over t. And what did they do? They simply sent x second over x to be equal to t prime. This is the method, name manager. This is how we go about it. First thing, you write it like this. Now once you do this, there is condition to follow, which is explained here. They say the equation is accepted to all x at time. Remember, this is an example. You do not have to write this all figure here. All you need to know is why is it minus or this, and I will explain now. We observe that the left hand side is independent of t and the right side is independent of x. They are already separated. As a sort, each side must be constant. So if they have to be equal to constant, they have to be to equate to what? To lambda. For convenience, we let lambda to be minus. Remember, if you read earlier on, you have different type of solution. You can go lambda greater than 0, lambda less than 0. It's either this or minus. Now there's a specific reason why when it comes to each equation, why we always use the minus lambda. They said we call this the separation constant. We choose minus lambda square because lambda square equal to 0 or lambda greater than 0 will give us trivial solution check, and that one is advanced level if you go to mathematics 5 and further math. So because we do not want trivial solution, Mr. Manager, we always equate this separation of variable here. Do you see it? This
Yes.
variable here to be equal to what? Lambda square. So these equations should be equal to what? Lambda square. Now next step is we deal with it. This is quite nice, right? The size of what I'm writing. This size, manager.
Yes, Mr. Ice.
It's fine, right?
Yeah, it's good. It's good.
Now what you do is you're going to have x square over x to be equal to what? Minus lambda square. You have to solve for this equation. Basically what you'll be having is x second to be equal to what, manager? Minus lambda square what? X. Do you
X.
agree? I can also rewrite it like this. X second plus lambda square x to be equal to what? Do you see it?
Mm.
Right now, remember,
Yes.
but this one here, this one is a form. Remember, when you start solving for ODEs, you have what we call general solution, what we call XCF. Did you guys write about it? It seems like yes, you skipped it. You skipped
Yeah,
it.
we did. I don't know if it's gonna come back or what.
No, you guys did it for test one or for test two.
I think we wrote it for test one. It was the last questions.
With the last question,
So I don't know if it's gonna bring them back or what.
that's gonna
Yes.
come for exam. Now this one here, if you have what is x square, you can call it what?
M squared.
Here, what can you call here?
Lambda squared.
To be equal to 0.
Yes.
Now you are solving for the what? For the particular solution of x here. So now what does it mean, manager? You have m squared to be equal to what?
Plus minus.
And m to be equal to
Plus lambda squared.
the
Plus or
root
minus.
of minus lambda square. So what happened
Yes.
here, manager? Remember, if this thing is negative, what do you do? What is m? You include the j square. You have j square lambda square because you cannot have a negative root. This is the third case where you have a conjugate expression. So in this case, the answer will be plus minus. This will come out of the root. You will be having j lambda. When you have a complex root, your type of solution is like this. XCF is equal to exponential, let's say alpha x. You have a cos x, no, cos beta x plus b sine beta x. Do you agree? This is the
I
general
do.
solution. So in this case here, the XCF, what is XCF, manager? Remember, we don't have the alpha. This part does not exist, so it's 0. So it means this part will not exist. It's only this one. Are you with me?
I'm with you.
So this side, I usually like calling this C1, C2. I don't like AB. So I will
Okay.
call it C1 cos.
And the two.
Let me call it lambda. You take the expression next to j here, which is what? Lambda. Remember, the variable here is x, right?
Yes, Mr. Church.
Plus c2 lambda x. Or c2 sine lambda x.
So to sine lambda x.
This is how it is solved, manager. So far, it's T. Now let's just double check we're on the right track. Yeah, that's what they get. But then they are calling them A, B. It doesn't matter. I just like calling them C. I don't know why I like it like that. So you do the same. You do 1 for this, for x. You also take this part of T. You equate with this guy. Do you see what we are doing?
Yeah, I'm following.
So now we come to the second one. We've got chi prime over chi to be equal to what? To minus lambda square. I think there's a 2 here. That 2 that we brought here. Make sure when you solve the equation, make sure x is alone. It's usually easier. It makes the equation easier. And bring the constant where there is the temperature here. Now, what do we do if we have to solve this quickly, manager? We have chi prime to be equal to minus lambda square. Can I write like this? 2chi, right?
Yes.
So now we have chi prime. If you bring this side, I can say it plus 2 lambda square chi. to be equal to 0. So we have the same thing. Now you cannot say, now because it is t prime, we simply gonna be having m. Here it was m squared because it was what? X second. Plus what, manager? Plus 2 lambda square to be equal to what? To 0. So do you agree in this case? What is m? M is equal to minus 2
2
lambda squared.
squared.
What is this type of solution? Is the type where m is equal to a constant, right? So the TCF here, you can call it TCF. The other one is XCF because the variable is f. TCF because the variable is temperature. It is simply okay, since this one is C1, C2, we can call this one C3. Or if you want, we can keep it the way it's in the book ABC, so that you can have a constancy, right?
Yeah.
It doesn't matter. You can have something constant. What do you think, manager? Should I post this video?
No, let's do it private, Mr. Ice. They will come.
Okay.
What do you think? Or did you feel like posting it?
I wanted to, but you're my manager.
Oh, you know what, man?
If you say no, I don't say. You're my manager. It's up to you. Whatever you decide, manager, I'll follow you.
Can you post it for a few hours and then
I can do that, and then I can lock it.
Yeah, let just few people to see it. When they tell their friends it disappears, they'll join.
I will do that. You're my manager. So this will be C exponential minus 2 lambda. I think it has to be chi, if I'm not mistaken. No, it's simply C minus 2 lambda square. Yeah, they have to be a chi. Yeah, they have to be a chi. So this one is a mistake. They have to be a chi. Why am I saying chi? Because the variable is time. Right, manager?
Yes, Mr. S.
Now, remember, the function u is a combination of x and chi. That is simply what it means. If you see from the beginning, they said u is a combination of what? X and what? Chi. So once you find those particular solution of x and chi, what you do, you bring them together. So basically you multiply them. So what you do is, what you are doing is, if I can call it in simple term, you are simply doing XCF times GCF. So what does it mean? It means u x chi is equal to what? Is equal to a. Now let me write it down here so that I can keep it. Xt is equal to a cos what? Lambda x plus b sine lambda x, everything multiplied by what? By c exponential what? Minus 2 lambda time. Now, this is the equation. This is the equation.
Okay.
That you're supposed to get first. This is it. Now, after you get the equation, manager, this is where the things start. You need to be able to use your boundary condition. What are the boundary conditions? Boundary conditions are the guys provided here. Do you see it? It will always be provided in your question. Let's start with this one here. Do you see it?
Yeah, I'm seeing it.
0. Let's start with that. U 0 chi equal to 0. As you can see, what does it mean, manager? It means what? X is what?
X is gonna be 0.
X gonna be 0. It means X equals 0, right, manager? So if X is
Mm.
0 in this equation, what does it mean? You have A cos 0. Do you agree?
Agree.
Plus B sine 0. Everything multiplied by what? C exponential minus 2 lambda chi. Remember, you are only substituting x where there is x by 0. Do you agree? So, what is sine 0? Sine 0 is 0, right?
Mm.
What is cos 0? Cos 0 is 1.
Yes,
You
sir.
can type in your calculator if you do have trust.
Nice one, I know. I know, Mr. S. It's 1.
Okay. Yeah, WhatsApp is just making me smile. Do you agree that if it is 1, what you are left is simply A multiplied by C exponential minus 2 lambda chi
Yeah.
to be equal to 0? That's what the condition says. We are just following the condition after that.
Okay.
Do you see what it means? Okay, manager.
I'm following.
What is 2 times 2?
2 times 2 is 4.
What is 2? It's a constant. What is the other 2? Okay, what is A times C? If I have to multiply A times C, what is the answer?
8 times C.
Mm.
It's gonna be easy. 8 times C is gonna be AC, Mr.
So
S.
what is AC, manager? If A is a constant and C is a constant, if you multiply it, what will you get?
Then I get a constant.
So do you agree that I can call, I don't know how they call it, let me see how they call it, so that I can keep the constancy. On the first condition, they simply call it A equal to 0. What does it mean? A times C, we can call it A exponential minus 2 lambda chi equal to 0. Remember, the aim of the boundary condition is to solve for this constant here. So if you have to solve for A, what is the answer, manager? A is simply 0 divided by exponential minus lambda chi. Do you see it or not, manager?
Now I'm saying it, Mr. S.
This will give 0. The only reason why they wrote A, because this constant times this C is still gonna give a constant. That's why they simply call it A. Now, what is the second condition? Second condition according to the problem is what? And this condition here, manager, this first condition here, in all cases, will always give you 0.
Okay.
And it will always be there because it's part of the, you see, part of the general solution. Second one is L chi equal to 0. So what they are simply saying, what is our condition here? Second condition is when we have 4 and chi equal to 0. You just follow the condition. You've got U 4 chi to be equal to 0. Just the way you see we did here. What's going to happen is what? You have A cos. Where there is x, you replace by what, manager?
By 4.
By 4. So what will you have? 4 lambda.
A cos.
Do you agree?
I agree, sir.
What else do we have? plus b sine, what do we have, manager? 4
4
lambda
lambda.
multiplied by exponential minus 2 lambda t. Now, what do we do? Remember, everything is equal to 0, right?
Mm.
Now, if a equal to 0, what does this mean?
If a is equal to 0,
Mm.
that's gonna be 0.
You agree that this part will be 0, right?
Yes.
Now, what do we have here as solution, manager?
B sine 4 lambda.
Multiply by whatever constant is here, let's call it c. C exponential minus 2 lambda t equal to 0. Do you agree that I can write b sine lambda x, sine lambda to be equal to 0? Remember, this thing will divide 0, just like here.
Mm.
Now you need to solve for this one. How do you solve for this equation where you have you need to remember your trigonometry, manager.
You mean the one you sent yesterday?
No, not this formula. You need to remember this. Do you know this thing? This trigonometric. Did you do it in high school?
Yeah.
Where you have cos and you have sine. Look,
Yes.
and you have sine. Now, if this is 0, what is this one? Pi, right?
The one you was. Yeah.
0 pi. I think this one is pi over 2, right?
Yes.
And this is 3 pi over 2. So basically,
Yes.
what this means, Mr. Manager, what are the angle which the sine is 0?
The angle which the sine is
Look
0.
what's happening. Along this side here, you have answer of sine. You have 1 and you have minus 1. If you take a calculator, you put sine pi over 2, what's the answer? You need to type it to see.
Yeah, let me do it. Sine 1 over 2.
Pi over 2.
Pi over 2. Getting 1.
Try 3 pi over 2.
What?
Try 3 pi over 2. It gives you minus 1.
Yes, sir.
Now, can you now try sine pi?
Zero.
Sine 2 pi.
It's the same answer.
What does it mean? So what are the angles where the sines are 0? You just call those angles now.
On,
Where the sine,
yeah, 180.
it is pi and 2 pi. So this simply
Yeah.
mean you can write b sine lambda to be equal to what? Sine pi.
To be equal to, yeah.
That's what it means. Or you can write. Oh, I remember trigonometry was nice when I was in high school. We had full problem on how to solve this one. Right? You also
Yes.
have what? To be equal to what? And so forth and so on. You can say 3 pi, 4 pi. What is 3 pi? If you put on the calculator.
Still the same.
If you put 4 pi, it will always give you 0, right?
Yes, sir.
So what is the angle the way the sine is 0? It simply means it is when you have b sine lambda to be equal to what? Sine n pi. Do you agree?
I agree.
Where n, which is which value? 1, 2, 3, 4, and so on, so on. Because if you put half, what does it mean? It's going to be pi over 2, do you agree? If you substitute n by half, what do you have?
If I substitute n by half,
You're gonna have
uh,
sine pi over 2.
yeah,
And that is not 0. Sine pi over 2 gives you 1.
I know. Yes, sir.
The only value that gives you 0, it is this guy and this guy. So that's why on your solution, they insisted that sine should be equal to what? N pi. And those n value should only be 1, 2, 3, 4. How do you call this number in good English? Is it integers?
You mean 1, 2, 3, 4?
Yeah.
Yeah, I think so.
Is it integers? How do you call numbers like half, 3 over 2, 4 something, or those fractions? How do you call it? But anyway, it doesn't matter. Yeah?
Okay.
If you don't remember it, is fine. But these values of n should or can only be this. That's when you come to this solution. That's why they say that b. Let me see if they send b on the other side, or okay. I see what they did. What they did from here, manager. Do you see what's happening here?
You mean where?
They simply remove the b. Why are they removing the b, manager? No, because if you have 2x equal to 0, what is x, manager?
2x equals to 0. Point B, x is gonna be 0.
Yeah, that's what's happening. They simply divide this thing like to only have sine pi on its own. Do you see it? But remember, I even forgot the angle here is 4 pi. Sorry, 4 pi, 4 pi, 4 pi. That is where they come with a conclusion of saying that 4 pi is equal to n pi. If you have solved trigonometric, I remember well, we did this when we were in school. When you used to solve this type of trigonometric questions, they can give you cos, let's say, cos 4x is equal to 0, and they want you to solve x. How do you solve x in this case? What you do is you have to look what are the angle where cos is 0. It is pi over 2 and this one. So you can come and say cos 4x is equal to cos pi over 2. Do you agree? I just want to show you the whole idea. The idea is to look for the angle that where the cos gives 0. Do you understand, manager? Hello? Yeah, lose network here. Are you with me, manager?
Yeah, I understand, Mr. Sorry about that.
When it comes like this, you equate this angle now. These angles are equatable. So you have 4x to be equal to what? Pi over 2. So now you can solve for the unknown x, which is pi over 2 divided by 8.
Okay.
That is how you do it. It's the same logic also here. So you equate the angles here, and this is what you have. And then you can solve for lambda here. Why is lambda called? Lambda is also part of Fourier series, but they said lambda n is equal to n pi over 4. And this is how you get this solution. Remember again the condition of even. Okay, lambda n is what you call eigenvalues. Yeah, you've done that in mathematics too. You guys did eigenvalues. N should be 1, 2, 3, and 4. You know the reason why, right, manager?
Yes, I do, Mr. Eyes.
So after doing this, remember, so far this thing is very easy. Look at what we did. You get XCF, you get TCF, You multiply them, you get the equation. After that, you use the boundary condition, and this one would always give you 0, which cancel this. And this part, remember, this thing will be repetitive for it. It's just a pattern. So from here, you move here, you get the given values. So what do you do after here, after using your boundary condition? Remember, you still have another boundary condition. You have exhausted this one. You have exhausted this one. Which one is left, manager?
What did you say, Mr. Ice?
We have used this condition. You see?
Yes,
We've also
I can
used
see it.
this one. What condition is left to use? It's all about using condition after you get the
last one.
the equation.
We left it to use the last one.
Which is this one? What? Ux0 equal to x.
Yes.
Remember, this thing is easy, manager.
Mm.
Ux0 equal to what? The function x. So what does it mean? From this equation here, where there is time, what do we substitute with? With 0. Do you agree?
Yeah, what this time we're gonna substitute with
If you
0.
substitute by 0, what's gonna remain here? It's only this part. I mean, look where we are substituting. X is remaining. Now you substitute time by 0. Where is time? Only on this side. Do you agree?
Mm.
And what is exponential of 0?
The exponential of 0 will give us
Calculator, manager.
1.
Every
Yeah.
number to the power 0 is 1. So what will be left? It's simply this: a cos lambda x plus b sin lambda x. Do you agree? Manager, you have to agree with me.
Now I'm agreeing with you, Mr. Ice.
If you don't, I have to re-explain. A cos
Now, so far we are going together.
lambda x plus what? B lambda x. I thought maybe you will ask me, why am I not putting the c? What's the reason?
You said this can be
It's
1.
gonna be no, not even 1. It's gonna be c here alone.
Yeah.
So what's the reason why I'm not taking c? Because a times c is a constant.
Okay.
That's the only reason. B times c is a constant. So you rather keep it a and b. Now remember, all these things is equal to x. So from here, how do you solve them? What do you do? Let's see how we go about it. This is where we use the given function, manager. Ux is equal to f of x will be 0 to infinity of bn sine n pi over x. Now how do we get here again? Okay, here we go. Yeah, I see why. Do you agree that this part here will be 0, manager? No, not the cost. The cost will not be 0. No. Let me look at this thing. Where's the given value? Bn sine n pi over x over 4. They replace the lambda. Okay. What they did, they replace lambda. Let's follow the procedure. I think we're gonna get it. We should get it, manager. You have a, right? Cos. Remember, we've got lambda's value here, the given values. Do you agree?
Yes.
which is what? N pi over 4 x. Do you see it?
Mm-hmm.
Plus b sine n pi over 4 x, everything to be equal to x. You see how we're going to solve this x here like this, this equal to this function. We're going to use what we call Fourier series. You've done that in mathematics 3. Now what is happening here, manager? What are the values of n that we chose here, manager? It is 1, 2, 3, 4, right?
Mm.
If you substitute any of this value here on the cos, what do you have as answer? It has to give you 0.
Yeah, it's giving me.
If you substitute 1, what does it give? Anaja, talk to me. Talk to me, we have to finish this problem here.
It's giving me 0, Mr.
If you substitute 2, what do you have? It will give you 0. For all these integers that you have here,
Same.
it will give you 0, right?
Yes.
That means this part here will not exist. It will be 0. So our solution here that we're going to use in the Fourier values series, it is b sine n pi 4. And this thing will be like this. If you get this example, we can solve all the equation of
Okay.
x to be equal to x. Now this is where we use the formula of the Fourier series. This formula is in the book of math, for whatever event function. Let's just copy the writing here so that you can hide it in the proper way. So it simply means when we have u x 0 of the function, let me see again how the writing of the function to be equal to f of x, which in this case is x. That's what they mean. It simply means solving this should be x should be equal to what, manager? The sum of n going to 1 to the infinity of the function bn sine n pi 4 over x. Do you agree?
Yes.
That is what they got here. Now, after writing this n pi 4x, so n pi 4x like this, after writing this, which they call the equivalent function, for you to solve this, you need to use what we call Fourier series. And this is the formula of the Fourier series. Let me take my math book. I will send you the PDF. I will send you that formula now.
Okay.
You know, I only use math 3 for all these classes.
You mean all these math classes?
Yeah, this class is gonna be long, eh?
You mean we should class to this class?
Yeah, because we have to finish this example, this recording.
Yeah, it's gonna be long, Mr. Ice.
Yeah, it's fine like that. Yes, manager. Let me see if I can find
Yes.
Fourier series here. Yeah, I'm saying for all the classes of math, I think for me, Math 3, the Math 3 book of Vucci is the best book that they made in math here.
Who's the author of Master book textbook?
Yes, I don't know because the page that has the cover is gone. I just use it. But this is the best one that they have done in that department. If you can understand, you even have beam application that you'll be doing in you're gonna be doing it in Math 4 here. Everything is in this book. That I understand.
What makes you understand?
Now I understand that we were wanted to pass. No, manager, this math thing, math is math. We can't be struggling for math. We need math to do everything. I can see it here. Fourier series of regular curves. I want the general formula, but if I don't find it, I will send you what I see here. It actually
Okay.
explains. Yeah. Let me send it. I don't know if I should send it. Should I send in the premium group or in our math phone?
And it's fine, Mr. S.
Onaja, you are
So
the
just saying, where you feel like you, huh?
you are the leader here. Whatever you say, I do. Okay, I sent in that group.
You send it on the, yeah.
Do you see the formula that says that an? Okay, me I'm gonna take bn because that's what we need here. Bn is 2 over L integration of 0 to L. Do you see it, manager? F of x, that's how you solve it. Sine of n pi L x.
Yeah.
Do you see it?
Yeah, I'm seeing
And
it's number
then
B.
you have whatever value they said an value. Don't worry about the n value. But what I wanted to show you is this formula here. Do you see it?
I see it.
When we use the Fourier series here, we have to know which one is our L. How do you know, manager? It is always provided in the boundary condition. Do you see under this guy here? What is the limit that follow? 0 and what?
0 and is it 4?
Yeah,
No,
0 and
L.
4. Do you see?
I see it. I'm seeing it here.
So what do you have? If we have to call it in this our case here, remember we are solving for
Yeah,
Fourier
0
series.
and L.
0 and L, which is 4 in this case. So if we have to solve for this function here, which they call Bn here, we follow the formula. It is 2. What is L, manager?
L is 4.
What is 0 to L? What is L?
4.
It's even a coincidence that you see even here. It's always going to be that this one, remember, it says n pi over L. That's why you see n pi over 4 here. Do you see it?
Yes.
Now, what is f of x? F of x is your function here. What is it, manager?
Which is
X.
it X?
Yeah, it's x.
Yes.
You want to have x sine of n pi 4 over x. This is what we'll be solving. Now, how do we solve this one? You use integration by part. You see now everything is getting cooked now. Math 2 is back.
Yeah, the pots now. No.
You need to know integration by part because you're always going to be having it here. Why am I saying that? Let me look at one problem here. I'm not doing it, I'm just showing you a problem. You can see from this problem here, determine the displacement of model following with a differential equation. Where is the heat? I don't see heat equation problem here.
Let me also help you check. I'm seeing the wave equation,
Yeah,
Laplace.
we're also gonna be doing wave here. It's heat and wave.
No, I'm not seeing the heat.
Anyway, if we don't see it, oh, this is it.
Should I check on the other book? Because there are two books apparently, no?
No, this is it. This is the heat equation.
Oh, okay.
You see it?
Yeah,
In
I
this
can
case,
see wave
what
more.
is in this case? What is the function?
Yeah, let me open it. You mean on the heat equation?
Yeah, just look at. Can you see my screen?
I can see it.
When you see where it's highlighted in blue, what do we see there?
Um,
100.
100.
It means what? Will you have an introduction by part here? Never, because it's a constant.
Mm-mm.
You'll have 100 multiplied by sine.
Mm.
You're gonna have a normal integration. That one is easy. Do you see it? You can already see what you'll be having. But if you
Mm.
have 2 minus x, you'll be having 2 minus
Part.
x multiplied by sine. It means you'll be having what? Integration by part.
Okay.
So you can see your solution by watching the problem. It's easy, this thing. How long is this recording already? It's 1 hour. I thought maybe 2 hours. So we are here. We are here. We're gonna finish
Oh,
this.
it's 1 hour now.
It's only an hour. It's just we started recording late. We were talking before I record. Now, manager, how do we solve integration by part? You need to remember this formula. What is the formula of integration by part?
Integration by part.
You need to remember it. I think it is uv minus vdu, something like that. Minus integration of vdu. Wait, why am I suffering? Let me check here in the solution. Why do I suffer, manager? Where I can see. Yeah, they just put the solution. Let's do it. Okay, if I remember well, this is what it is. You have dv. You have dv. Oh, I'm even seeing this thing here. This heat transform here. Use Laplace. This math book is very nice, my brother. I won't lie to you. I will never sell this book. Oh, okay, I see it. I see it on the math book. Oh, this math book. Good, nice. It says UDV. The answer is UV. Oh, I was right, manager. I was right, manager. Minus integration of VDU. I was right, oh, manager. Now it is important to choose which one is your V and which one is your U. Remember, you need to start first. You have the integration and the derivative. So now, when you have a we need to remember these rules as well of integration by part. When you have a polynomial and a trigonometric function, which one comes first? Which one comes as the integration? Which one comes as derivative? Now, manager, when you have x and this, you need to choose. The aim is to get the equation easy. Do you agree?
Yes.
If you differentiate sine, let's go like that. What will you have?
Madam, what is it, Mr.
If
Yes.
you differentiate sine, what will you have?
If I what?
You differentiate.
Sine, I'm gonna have cos.
If you integrate x, what will you have?
If I integrate x, I'm gonna have
You're gonna have x squared over 2, n plus 1 over.
yeah,
Do you see
yeah,
that?
yeah, x squared over 2. I see it.
Do you think you are solving a problem when you do that? You still have x and sine mixed. You're not solving anything.
Yeah.
But if you differentiate x, what do you have?
If I differentiate x,
Mm.
I'm gonna have 1.
So what does it mean? You always choose the polynomial as what? Derivative. The aim is to get the simple expression.
Okay.
Do you get it, manager?
Mm.
If I choose my u, which is the derivative, which is what? X. Do you agree? What
Yeah.
is du dx? That's how it works. Follow my step, yeah? It is what?
I'm following your step.
So it means du is equal to what? Do you agree?
Mm.
Well, what does it mean? If you have a polynomial and it's trigonometric, always take your u to be what? X. Why? What's the reason, manager? The reason is simple. If I add x squared, right? If I do the first integration by part, it means I'll be dealing with what? 2x and whatever will come. Do you agree? Just see what I'm trying to say. What I'm trying to say is we do the integration by part to have a simpler expression to integrate. One thing you will notice, as you keep differentiating x, it reduces. But if you differentiate sine, it gives you cos. If you differentiate cos, it gives you minus sine. Nothing is changing. You have it just trigonometric. Am I making sense, manager?
Yes, you are.
So it means the polynomial should always be your u, the guy that you'll be differentiating. That's what it means. So if you have x cubed, so it means you will be doing integration by part, it's gonna reduce to x. You're gonna be until you get a simple expression. Sometimes you can do 2-3 times, but I don't think at this level they will make it hard like that. That one you did in math too, so you don't have to worry about it that much. But just remember which one is priority and what to do. Now, manager, it means we have dv. dv is sine n pi over 4x. Now, what is v? V is the integration of this. What is the integration of this, manager? What is the integration of sine here? Okay, forget about what you see here. If you have cos x, right? What is the differentiation of cos x, manager?
Of what cos x?
Yeah, differentiation.
It's gonna be negative sine x.
Now, what is the integration of negative sine x?
Differentiating of negative
Remember,
sine x.
this is the differentiation, this is the integration.
Okay.
Now, I want you to see it, you don't see it. I'm taking my time, and you need to see it. Let me say you have sine 2x. What is differentiation of sine 2x, manager? Differentiation.
It's gonna be 2
2
cos 2x.
cos 2x. Now, if I ask you to integrate cos 2x, what will you have?
I'm gonna have actually I forgot integrate.
No, you're going to have this as answer.
Okay.
Do you agree for you to have this an answer? You need to have 1 over 2. Do you agree?
Yes.
Multiply by this 2 that is here as a constant, so you will have 2 sine 2x. It brings you back here. So in another way, if you don't see it, let me just remind you how it works. Integration of sine ax is simply minus 1 over a cos ax. Integration of cos ax, it is simply 1 over a sine ax. Why is it like that? If you differentiate sine ax, what do you have as answer here, manager? It will give you cos ax. If you differentiate this the way it is, it will give you this. So in this our case here, manager, let's finish. Let's do this and finish. I need to rest. I think I'll have to study. What is this one here? Remember, I said it is a 1 over a. So let me write. Let's look at your a. Everything here. N pi over 4. Do you agree?
Yes.
When I say 1 over a, it has to be negative because it is sine. 1. What is a? It's going to be n pi over 4. I'm taking it step by step so that you can see what's happening. It's going to be n pi over 4 multiplied by what? Cos n pi over 4x. Now what does this mean? You basically have 1 over ab. So what is the answer? You're going to have 1 multiplied by b over a. So that's why you will see your v here is simply going to be 4 n pi cos n pi 4 over x. So if you have something like this, manager, what you have to do, you can simply switch them. You bring the 4 on top like here, and you have get your dv. But don't forget that there's a negative here, because it is what? It is sine. Now if we have to solve for this, what is 2 over 4, manager? It is half, right? I can write half outside. Open my bracket for the integration by part formula. It says uv. What is uv? You come. This is u and this is v. What is uv? It is x multiplied by this. Do you see it?
Yes.
So let me put this minus outside here. Let me put minus x, and then we have 4 n pi cos 4 n pi. No, what am I writing? Plus 4 pi. Oh, why am I writing for n pi over 4 x? That is your uv. Now you have minus of the formula, integration of v du. V du. What is v? V is this one. Do you agree, manager? This is v. What is du? We say that du is equal to dx here. Do you see it?
Yeah, I see it, sir.
So now we have minus 4 n pi cos n pi. Sorry about my writing there, but this is cos. Cos n pi over 4 multiplied by x. Remember, du is the x. So this is what you have. Remember, your limit of the integration was given here, 0 to 4. So everything here is 0 to 4. But before we solve this, we need to solve this integration inside here first. So if we have to write it, it's half minus x 4 n pi cos n pi 4x. The minus can come out here. Do you see it?
I see it.
Yeah, this is a lot of effort that I put today. It's a lot of effort today.
Why are you saying that?
Huh?
Why are you saying so?
Hey, I haven't been pushing this hard, manager. I've been lazy lately, but now I'm feeling myself.
Yeah. Keep the momentum, guys. Must keep it.
Now, if we have to do this, what do you have? You have half outside here. Remember this half, right? It is step by step so that when you follow the video, you can actually understand what's going on.
Oh, okay. The video you're gonna post it after class?
Yeah, definitely. I'll load it publicly. Now remember, manager, do you agree I can take this constant out, right? Now, if I have to integrate this, what will I have?
Which
Remember,
one?
I said we only swipe what is on top and what is here. So I will have multiply by 4 over n pi. There is no, remember when you integrate cos, it is positive. Cos is only negative when you differentiate.
Okay.
It becomes sine. Now I have my limit from 0 to 4. Now what we're gonna do, we're gonna substitute upper limit and lower limit. Right, manager? Now we can save time here. How can we save time? Let's just follow it on the right track. They got this. I think we have the same expression, right?
We do.
Because this one becomes square. What is this one? And this one is minus 4x. We got the same expression, I'm pretty sure. Yeah, it is the same one. Now, if we have to substitute upper limit minus lower limit, do you agree that, manager, when we substitute the lower limit, everything will be 0? Let's substitute the upper limit. You will see. Let me just do step by step. Let me not rush. If I substitute this, what will I have, manager? Where there is x, I substitute by what? 4. Do you agree?
Yeah.
So I'm going to have what? Minus 16 over n pi cos remember this is n pi x. Do you agree?
Yes, I agree.
Cos, when you substitute 4, what will you have? What's going on here? We'll have cos n pi. 4 will cancel 4 here. I hope you are with me, manager.
Yeah, I'm following.
Now we have plus, this one becomes square. You have 16 n square pi square when they multiply there. Now, what do you have? You got sine of this. When you put 4, it will cancel here. You have n pi. Right? It is the upper limit minus. On the lower limit here, manager, let me just save time. If you substitute, lower limit is 0. If you substitute 0 here, what's going to happen to this whole part? Remember, x is multiplying everything. If I put 0 here, what's going to happen to this whole part here?
It's going to be 0.
If you substitute 0 here, what is sine 0?
You say sine 0 is 0.
So it means all this body also will be 0. Do you agree? That's what I said. Don't worry about the lower limit of 0 there. This is what we've got. So from here, what do we do? Let me see. They got minus 8 pi cos.
Yeah, I see it.
Remember, what are the values of n, manager?
1, 2, 3.
1, 2, 3. Do you agree? If you substitute any value of n here, what's going to happen to this expression? If you put, remember,
The whole expression.
What? No, if you put any value of n here, 1, 2, you're gonna get answers for this. But for this guy here, where there is sign, if you put any 1, 2, 3, what's gonna happen to this expression?
I think you're gonna get 0.
What you think is gonna get 0? You can put in the calculator and check.
Let me check.
Don't think. Put.
Hmm?
Don't think. Do.
Yeah, let me do it.
Do and see. So it means you need to redo this thing.
Yeah, I'm gonna redo it when you. What's the video? What's the eyes? Yeah, but zero.
So if this, it means that this here, that's one of the reasons why you see on this solution, that part is not written.
Okay.
So here, manager. So if this gives 0, what are we left with? We are left with half multiplied by what? Minus 16
Yes.
and pi cos what? That is how you see this solution. How they came about this one.
How many marks do you think this question is gonna have?
Usually carry a lot of marks. So if you multiply with half here, this will give minus 8 over n pi cos n pi. Now you are not yet done. You still need to solve. You need to check for odd and even so that you can write your solution in x and u. After here, this is what you have as your bn value. Is minus 8 n pi multiplied by cos n pi. From here, you're simply checking for even and odd number. What do you get as answer? Is it a negative or positive? When you put 1, you can always check with 1. What do you get as answer here? When you put n by 1, you got, I think cos pi gives you negative, you got 8 over n pi. You can push the calculator and check.
Sure.
One is even or odd? I think 1 is an odd number.
Yeah.
If you put 2, what do you have? You need to get negative 8 over n pi. So it means if you want to write the solution in this case here, manager, the way they wrote it here, what they simply did is they wrote u as function of x. There's also another form of writing this. I think I will show you that if I remember it. This is just a explicit form of it. They says it is like this. No, I remember well. I think this solution, this part here, there is a mistake here. There have to be a mistake there. But anyway, let's write it and see. They said for odd number, basically, what does it mean, this solution? Okay, let me write it in the way that it's supposed to be written first. Normally, you can write it like this. You've got 8 over n pi cos pi. Do you see, manager?
Yeah, I'm following.
Minus 8 over n pi cos 2 pi. You go plus 8. But remember, how can I explain this in the easiest way? Let me do this. Do you see the reason why I am removing the n? Remember, manager, I want to show you something. Let me say it in the easiest way. Now, you want to find your solution. You know, when you put an odd number, you have positive. When you put an even, you have what? Negative. Do you see, manager? When I'm writing my solution, I say if n equal 1, what will I have? I'll have this answer here. Let me see if they are also substituting the n. Now, when I come to this second solution here, if n equal to 2, Let's keep the n. I will see after. Let's keep the n. 8 n over pi cos of 3 pi plus minus 8 n over pi. Now you have cos 4 pi. Do you agree that this solution will keep on going and going?
Yeah, it will keep on
That is how
going.
you write it. You close like this, and then remember, this thing is multiplied by exponential. If you remember well, Mr. Manager, if I can scroll, I know it's a bit up here, somewhere along here for the equation. We said it is multiplied by what? Exponential minus 2 lambda t. But what is lambda? We say that lambda was this one, n pi over 4. So the answer, the whole answer, will be multiplied by exponential minus 2, where this lambda will replace by n pi over 4t. This is how you write it. Now, the concern that I'm having, Manager, do you know what's my concern?
Mm-mm.
My simply concern is when I write it like this, right?
Like how?
The way I write it, odd, even,
Uh,
odd, even. If I also have to substitute these values of the n here,
mm.
let's say if n equal to, when I say here, n here is 2, so it means, should I put 2 here? That's where my concern is, but I will find out with the lecturer for that. For now, you can keep it like this. The other way of writing it is the contraction form that you see on your, usually sometimes he asks it like this during the test. Or we can give it to him the way it is given in the general form. But this general form here, I can see it has a problem. It is lambda square, yeah. So it means
Yeah.
this thing here has to be square. It has a problem. But let's see how. If I had to write it, what I will do is I would write 8 over pi outside. That's how you write it, actually, not if I have to write it. That's how we write it. Let's just follow to see that we are on the same page. We are here. Now you have the sum of n going toward n to 1 going to the infinity of what is the function? Of what is it again? Of sine n pi over 4x. Sine n pi over 4x, like this, minus the sum of n equal to 1 moving to the infinity of sine n pi 4 x, like this. Everything multiplied by exponential minus 2. Who's calling me at this time? It's my brother. I will call him back now. Manager, let's finish this so that I can call my elder brother.
Is a biological younger brother?
Yeah, my elder brother, yeah.
Oh, he's calling you from where?
From Congo.
What time is it that side now?
9:36.
9, eh?
I will call him just right away now. Manager, this is it. Now, what do we do here? Yeah, it means here, you can come here and write, you have this as positive when you have it. What is the value of n when it is positive? When n is 1, 3, 5 going on. This one is negative when n is what? 2, 4, 6, and then you put going on. This is the way of writing it.
Okay.
So please look at it, and yeah, I'm just gonna stop the class now. Let me call my brother.
It was a nice session, Mr. S.
Thank you, manager. I'm gonna post it now. It's an hour and